Saraf, Parth, Vikrant, what is your progress?
Yes, sir.
What is your progress? Could you do the circuit designing?
No, sir, I couldn't do that.
Harsh Kumar Jha,
No, sir.
So yesterday we were just given, like we were just shown the code how to design an ADC and all that, but we were not shown the circuit.
the circuit was shown. Na? Gargi showed you the circuit with crystal oscillator and DAC interface.
But that
You,
was for the filter part, right?
yeah, you only after you interface ADC and DAC you can design a filter. That is the first part. The circuit remains the same for ADC DAC interfacing and no, then for filter, but the code will change. After you have got a digital signal converting from ADC, you apply a filter to that. That is the only thing that changes for the filter case. But in case of ADC DAC interface, whatever digital signal you get, you feed that to DAC. Okay, Abhijit and his hand. So Abhijit, you have made some progress.
Yes, sir. I simulated that code.
Okay, good. Share your screen and show that.
Okay,
So
sir.
those who give share their screen and give that demo today, they will get full marks because this is a part of your evaluation. Demo, like generally in embedded lab, embedded systems, be it lab or theory. No? So the evaluation mode is that you have to share your screen or you have to come in a Google Meet. If you ask you to come in a Google Meet, and you have to show whatever you have done it,
Is it
and
visible,
Google
sir?
it with. Yes, yes, yes.
So this is
Okay, okay. Stop the simulation. Uh, Click on this signal generator. Change the frequency to 10 kilohertz.
I think there will be some issue in this case.
Just change the time scale.
Yes, sir. The wave is distorted, sir, in this case.
Here it is distorted. Increase your time scale. Yeah, increase more. You see the sinusoidal wave was the input, and the output you are getting a distorted waveform. So who can tell what is this phenomenon called as?
Aliasing?
Yes, Amri Amrit Kasya. Amrit Kasya has told the right answer. This is called as aliasing. Aliasing, what happens is that there is a loss of information when sampling frequency, when it violates the Nyquist criterion, that the sampling frequency, the minimum sampling frequency is not less than 2 times the original frequency, then aliasing happens. So there is a loss of information. So this is what is called as aliasing. So in digital filter also, when you do implement the filter, you will see the aliasing when you increase input frequency. So that you should observe in filter case also, in case of filter designing also. Okay, Abhijit, you can stop sharing.
Okay, sir.
Okay, other than Abhijit and anyone else?
Sir, I have a doubt. Like, is it taught in the class? Like, if we are asked to present.
Sorry, can you repeat? I couldn't get you actually.
Like, sir, how do we write the code? Like, I don't know the basics of it. Like, I don't think it was taught in the class.
It will be taught in class, but the basic things you will have to learn on your own. So there is a
So,
data set, there is Majdi book that has been given. So you did not learn the assembly language completely from scratch, but whatever is required for no this embedded codes that you have to learn, like basic operations like addition, subtraction, assigning value to registers. These things you have to learn. If you are interfacing a external device, how it will be there. So like here you are
so, uh,
interfacing external DAC.
yes, sir. But like, do we have to read it by ourselves or it will be taught in the class? That's my question.
Some part will be taught in the class, not everything.
Okay, so like, whatever you are asking to present today, like, is it taught in the class or not? Like,
No, whatever I'm asking today, I have already given the code in ADC PPT. So if you just copy the code and implement, it's like you have learned how Proteus circuiting designing and interfacing DAC. So then you have to understand the code and you have to expand it to for a filter application. So
okay,
things will
like
be
we have
taught
to
to you.
copy the code,
Many
right?
things will be.
Like, as of now, we have to copy the code, right?
As of now, you can copy the code for whatever is given in the ADC PPT. But
Oh, okay.
but going future, digital filter code is not given to you, so that you cannot copy. So you have to understand the ADC code and expand it to filter code. So filter means there you have to go get the coefficients. After you have achieved the coefficients, you have to
Yeah, yeah.
do the
Mhm.
convolution operation. Convolution means multiplication and addition. So if
Yeah.
you learn how multiplication happens in assembly, what is the syntax for addition, then you expand it to convolution. So that's how filter application will be there.
So what do you have
Oh,
to do in this week's lab?
This week's lab, you have to show this thing: ADC DAC interfacing and filter implementation.
So filter implementation, how can we like write the code without even going through the theory? We need some time to go through the theory, right? Only then
No,
can
there
we
is
do the,
there is
write the
ample
assembly
amount of
code.
time. There is you will be given time. There is
So,
no
but
issue.
some of us
But
have lab tomorrow.
yeah, Wednesday people lab. I am their TS, so we will help you on writing. So once you come to the lab, your task is to write that code. No? So you have to write the code.
Okay.
Sir, I had one
Hello,
request.
sir.
Like, if we have time today, like, you can see most of us have not completed that thing ADCDAC. So, won't it be better if you could teach us like the basics and whatever is required?
Basics actually, sir is going to teach. That is why I'm not touching that. No?
So
Because
actually,
But we
because
have
we don't know
time
the
right now,
basics, we are facing
and
some
it would be
difficulties.
a
so
waste
like
of
no,
it's
time
just like
if you
copying and
ask us to
pasting
slow
only.
down.
Like we are not learning anything new. Like,
no, you'll learn all the things. Basically, sir will start from beginning of data center many concepts. So I will not be teaching that. So sir is going to teach that. So I cannot disturb what sir is going to teach.
So actually, because we don't know the basics, we are facing some difficulties in writing the code.
The codes you can get it from dataset. That's what I'm telling. If you just open the dataset, you see what is the syntax. Now what is it is being used for. You will understand what it is exactly. Even if you don't get no, if you have even if you're bored with the dataset, like you don't have interest in going deep into dataset, you just make a Google search of the codes that we have given. The basic operations you'll learn. Okay, anyone else ready with the demo?
Sir, I have done, but sir, once can I present my screen and share? Like, I have some problem.
Yeah, you can share.
I'm not getting the output.
Open your code. Okay, go to your notice. The ADC 0 you have connected, the signal input connected to ADC 1.
Okay. Sir, it is coming like this.
Yeah, so expand your time scale. Yeah, so this is aliasing happening because of frequency issues. So go to close the simulation, stop the simulation. Go to your signal generator, double click on it.
I gave
Should want
frequencies 1 only.
is 0, offset 1 volts. Okay. Make the frequency 10 hertz. Decrease the time scale a little more, make it 10. Okay. Stop the simulation again.
Sir, maybe she has not set the crystal frequency to 8.
Yeah. So
Okay,
first,
okay.
you see make it 16 megahertz.
16.
Okay. So go to your code right now. Actually, the first time the issue was you had given input to ADC 0, but in your
Yes, sir.
code it is defined ADC 1 as the input. So wrong input. That is why it was the ADC was not able to operate. But now there is issue of frequency. So just double click once on 8 mega 32. The clock frequency. No, leave it. Keep it to clock frequency, and make it 16 megahertz.
Where, sir?
The default that is written. No?
Okay.
No, it's not working. So go to 8 mega 32 again.
So, like, there is one thing that I have connected this A1 to port in B port of 0.
That should be fine. The signal will be inverted.
Okay, it will be inverted, that's it. But I don't know.
Yes. Yeah, so code wise fine. Go to Proteus. Double click on Atmega 32. The clock frequency changes to 1 megahertz. Okay, and change the input frequency also to 1 hertz. Change the time scale, make it 2 milliseconds. No, to make it for 20 or 50. Okay, okay, okay. Keep it here. Okay, now open the code. Stop the simulation. Okay, open the code and scroll up in your code. So that LDI R16 0x87. So that you change to maybe change it to 383.
83.
Yeah. Now build the solution. Okay. The circuit voltage values are proper. What
Yes,
we have
so
connected to R2 and other things.
this is minus 15
Okay.
V and this is 2.56 for V reference. And this is 5.
Okay.
Hello, sir. Sir,
Yes.
this happened with me also when in the ramp generation simulation. Like when I connect the bits in this sequence, then the wave is distorted. And when I connect in MSB to LSB, then it is coming precisely.
Oh, A to A1 if order is reversed.
Yes, sir. Like,
Okay.
Okay, sir, I will change the order.
You just right click on it, and I think if you X mirror Pro, you will get the reverse one. Yeah. So no, okay. You have to make the connections also proper. Like no, right now the whatever connection it was there previously, now it is the same
Okay,
connection.
okay, okay,
You
sir.
have to delete the connection and make it. Okay. You make it and let me know.
Okay, sir.
Okay. Anyone else? has got the demo?
Yes, sir. Can I present?
Yeah, no, sir, you can present.
So, yes, sir.
Okay, change the input frequency.
So take 2.
1 kilohertz, make it 1 kilohertz. One K also works fine. Just adjust the time scale, you'll see the distorted waveform. Yeah. Okay. Okay, anyone else?
Sir, it is coming. Like I've made the connections properly.
Okay.
Should I present the screen, sir?
Yeah, you can present. No time scale you increase, make it 100 millisecond. Yeah. Okay. Okay, Mumta, you can stop sharing. Okay, anyone else have got it?
Am I present?
Yes.
Is it visible?
Yeah, it is visible. Okay. Change the frequency to 1 kilohertz. Okay. Okay, Arundhati, you can stop. Anyone else is there?
Can I share? I'm getting a bit of a distorted response.
Yes.
I might have done some mistake in circuit. Let's see. Anyways. Yeah.
Time scale you adjust.
Increase or decrease?
Okay, fine. Stop this. Input waveform, double click on that.
Should there be a ground over here?
No, frequency make 1 kilohertz.
Yeah, frequency is 1K only.
No, frequency make 1 hertz.
Oh, 1 hertz.
Yeah. And no, again, no. Wait. Double click on input waveform.
Oh, wait. Just a second. I think there should be a ground here, right?
Yeah, there should be a ground here there, and there is one more change in input waveform also.
Okay. Yeah.
Offset, you make it 1 volt.
Where is the
The top
offset?
first one.
Oh, okay. Okay. I'm gonna run this.
Keep it 100. Channel A voltage scale, you make it 2 millivolt maybe. Or 2. Make it 1. Okay, there is still some part of the waveform is.
Very clear.
Yeah. So okay, stop the simulation. Double click on that input waveform. What are the details? Okay. Okay. Frequency make it 10 hertz. And this voltage values are proper to BE and B reference positive.
Minus 15.
15.
2.56 and this is 5.
Okay. Okay. Now reload the.
Yeah, some clipping is there. Oh.
Some clipping is happening. Okay, it's fine. Some the offset value, if you just change it to make it maybe 0.8 or 1.2, the clipping will go most probably.
So what should I do about this Proteus? This crashes every time. Let's see, now this is gone.
This issue I am also not sure how to solve. I have seen for some people previously also, but
So like I can't even save my schematic.
you can't even save your schematic.
I don't like, sometimes I forget to save and it crashes and it's gone, like the entire schematic.
Yeah.
Should I like just purchase the paid version or what?
No, this you installed which one? The one I gave or
The one you
got
gave
it?
only.
This the one I had given has some issues.
Yeah.
The newer works left side. This one. Okay, you see if you can get some other card version.
Okay.
Okay.
Just
Okay.
stop sharing.
I take your demo as complete.
Okay.
Okay. Anyone else? Shubham K. Yes.
Yes, sir, I'm sharing my screen. Is my screen visible? Hello?
Yeah.
Yes, sir. So I'll just run it and show it to you.
Okay. Make the frequency 500 hertz.
Yes, sir.
Okay. Okay, Subham.
Okay, yes, sir.
Okay, you can stop, sir.
Yes, sir.
Okay, anyone else? Yes.
So
Yes, Amrita.
I'm getting somewhat unexpected results.
Okay, share your screen.
Yes, sir. So is my screen visible?
Yeah.
Yeah. So when I'm running it,
Your
uh,
screen is only half visible to me. I think you'll have to bring the oscilloscope to center. I can see your
okay.
oscilloscope, but I am seeing only half.
I don't know why it's.
Okay.
Is the oscilloscope visible now?
Nah, yes. Mm, make the voltage scale increase for the channel B. Make it 1 volt. Okay. Close the oscilloscope. What is the input waveform? Okay, input is proper. And check voltage output of others.
Uh,
Yeah,
Here
check
it's
the R.
minus 15.
Okay, connected to R2.
It's
Okay,
2.56.
R4.
It's 5.
Okay. Okay, so you have connected that ground to AVRF and AVCC because I cannot see the right side of that part.
AVREF. Let me. Why it's not coming?
You
Yes,
have
I have
connected the
connected the
ground.
ground.
Okay, fine.
How to
Fine.
slide this window?
Okay, no need to slide. Open your code.
Yeah. Just a minute. Let me stop sharing and share again. I guess it's not getting shared.
Okay.
Is this visible now?
Yes. Scroll down. Okay, code is proper. Go to your circuit
Yes.
and double click on Atmega 32. Clock frequency is default. Okay, and what is that external frequency?
16 megahertz. Yeah.
Okay. Go once just try Atmega 32 clock frequency. Make it 16 megahertz. Double click on Atmega 32. The clock frequency which is set to default, make it 16 megahertz.
It's still the same.
Still the same. Okay, stop the simulation.
It's coming like this now.
Okay. Okay, there is some circuit issue. This is fine. This output is fine. There is just some clicking. If you adjust the offset, this will go. Okay, now change the
Okay.
frequency to 100 hertz.
So,
Adjust the time scale. Okay. Okay, Amrita, you can stop.
okay.
Ayush, it will be last demo today.
Okay, sir. Hmm. So is my screen visible?
Yes.
So it's for 100 hertz and I'm running the simulation.
Okay.
So should I change the frequency?
Yeah, you can change it to 1 hertz.
Oh, sorry.
Maybe 10 hertz, not 1 hertz. Make it 10 hertz.
10 hertz.
Okay.
Okay, sir.
Okay, Ayush, you can stop sharing.
Yes.
Sir, I'm getting some clipping in mine.
Clipping, you can, if you're getting clipping, it's okay. Sometimes those circuit errors comes up, some circuits. So if you just adjust the offset, you'll see the clipping will go. Increase the offset, decrease the offset. You just do a little bit something with the offset, it will go.
Can I
Yeah.
show?
Yeah. So
Bottom but
yeah. Okay, close the oscilloscope. Show me your input waveform.
frequency is 10.
Offset, make it 1.5. Okay, it's still there. I change the offset to 0.5.
Okay, between these two.
So just like it's like this kind of clipped output is okay. Generally, we don't like consider it as a fault because this is circuit errors. So if you just adjust the offset, keep adjusting the offset, you will see somewhere this will go.
Okay, sir.
Okay. Okay.
Sir, can I
So
present?
fine. Yeah. Anything else?
Sir, do I need to show something else?
No. Fine. You can stop sharing.
Okay, sir.
Sir, can I share my screen?
So who is it?
Harsh Singh.
Okay, Harsh. This is the last. Then we'll stop for today. Harsh, you can share. You are the last.
So can the rest of us show in the next class? Will it be fine?
No, it we'll give time for that. I mean,
Hello, sir.
Next class mostly sir may take class theory, so upcoming weeks you will see.
Yeah, hello, sir. Is my screen visible?
Okay. Yeah, Harsh. Okay, you can stop sharing. Okay, fine. Okay, so that's all for today. We'll take more demos in coming weeks, and because sir had some health issues, he couldn't take class this week, but he will be available from next onwards. Okay, bye.
So,
Yes.
so there has been some confusion regarding the lab slots, and it's still not clear about the swappings and all.
That actually I heard a lot from many students, but the problem is it is not in my hand. It is completely with professors. But what is the latest update I have is this Sunday. I mean, the day before yesterday, AK Dev sir did the final divisions, final slots, everything. So he has allotted. So if some people are still having some issue, maybe you can check with AK Dev sir.
Sir, how to know that allocation, because we are not informed formally that we are in which slot?
No, formally he has done the division with whatever division, and that has been shown in the departmental website. And and whatever swappings were allowed, so he has included that also. So
So, sir,
yes.
can you share us the roll number list with the slot details if they?
No, I'll not be able to share because I don't have access to ERP of professors.
Okay. Because I have mailed him yesterday afternoon only and didn't got any reply from his side.
Sir,
Yeah.
if the professors have allowed our swap, so can we join the batches accordingly, like the swap batches accordingly?
Yes.
Cool.
Yeah. So those clarity can, Amrita, these clarities can be given only by professors. It's not in my hand. If it would have been in my hand, probably I would have solved it much before.
Yes, sir.
So like this first week, most of us is either missed our labs or weren't evaluated because our roll numbers were not in the list. So can this, like the past week's evaluation, be cancelled for all, because it's unfair for those who weren't even aware?
No. It's in here. What we follow is that we give time. Like if you couldn't show something in the first lab, we allow him or her to show it in the second lab.
Okay.
Yeah. So in first lab your evaluation is missed. Second lab you can give the evaluation.
Okay, and is there a way we can know what happened in the first batch? Like, or was it same for all the Monday, Friday, and Wednesday?
For everybody, it was same. The Proteus familiarization experiment, the LED and Sawtooth waveform. But after that filter onwards, things may change a little bit. It will remain same mostly. Like if one professor asks you low pass, another professor may ask you to design a high pass. So it may change like that, but the core experiments will remain same.
Okay.
Okay, guys. I'm leaving this. We're closing for today.